Hello everyone and welcome to an exciting part of this web application development series. So in this part we are going to see how we can use Docker Compose to connect together multiple containers. So in the first episode we saw how it should be done with the Flask application. But this Flask application needs to connect with a database, and we are going to use the Postgres database for that purpose. And also we need to connect our application with a reverse proxy. So this means that now we have three containers that needs to be spun up. So it is going to be very exciting to see how we can use Docker Compose to grab all the containers together and fire them in just one command. So let's get started. Alright, so now that we have done everything that we need to have the Flask application running in a container, then there are two more services that we have to spin up that are considered as a best practice when we host an application in production. And I'm talking about the database instance, which is Postgres, that we already know that we have to set up. But I also talk about the reverse proxy service that we need to execute. Now, a reverse proxy is a dedicated HTTP service that is going to be responsible to handle all the requests that are going to arrive from your clients. And actually, when it comes to production environments, leaving this task to the Flask Gunicorn itself is not considered as a great idea, and it is more convenient to use a service like NGINX to basically handle all the requests that are coming from different clients. So this is why we have to spin up a database, and as well as an NGINX, which is a reverse proxy service that needs to be running in our production environment. Now that means that we now have three containers that needs to execute in production. So first is the Flask application, and then we got DB and also the reverse proxy that I talked about. So now we have a kind of problem because we have to figure out how we are going to connect those three services together. And for this purpose, Docker comes with a special utility that is called Docker Compose, and it helps you to define services and connect them with each other basically by creating a basic YAML file. And in that file you can specify what are the services that you want to execute in one shot, and then basically we will be able to execute those three services with only one command. So let's go and see how we can set up Docker Compose by writing a basic YAML file which will be responsible to define those three services that I talked about. Alright, so let's get started. Now first, I will start by creating three directories, and each directory will represent a container that needs to be created. Now each container is going to have its own and unique configurations, so this is why having them in separated directories could be a great idea. So first, let's go and create the web directory, which will be basically everything that needs to be included for our Flask application only. So let's say web, and then I will create two more, and the other one will be DB. So we might also include some necessary configurations about the database itself, and the third one will be the configurations for the NGINX. So let's call it something like proxy, like that. Okay, so now that we have done this, we have to move the market directory and then the Docker file requirements and then run.py, everything that is pretty much related to Flask, under the web directory. Now, I'm not going to do this with PyCharm because it will automatically do this by refactoring the imports and all the libraries, and this is just going to screw up everything. So besides, I'm going to open my file explorer in Windows and complete it from there. And now let's open this directory, and here we'd like to move again the Docker file requirements, run.py, and the market under the web directory like the following. And now that I have done this, then the PyCharm should automatically synchronize with these changes without really changing the code of the Python itself. So if I go back to PyCharm, then you can see that everything now looks okay. Alright, so let's start with the proxy directory and really design the NGINX service. Now, first, we'd like to create a Docker file to really include some information about the featured container that needs to be spin up based on the NGINX image. So I will go here and basically create a Docker file like that. Now remember that its name has to be Docker file and really not just a random name that you want to come with. So remember to name your file exactly like that. Okay, so now we have the Docker file, and the other file that we'd like to create in this stage is another configuration file that the NGINX is going to use. So I will only go here again and create a new file, and let's just name it conf like that. And let's go and first work with our Docker file and write some Docker syntax code that will be responsible to create an NGINX container. Alright, so inside this Docker file of NGINX, I'm going to specify several lines that will be responsible to override the default configuration that the NGINX service comes with. So when we spin up a default NGINX service that we pull its image from Docker Hub, then we will end up by pulling a default configuration that this service has, and we are interested to change it a little bit to really support running the Flask application with this reverse proxy. So first, I will specify that I like to pull a specific NGINX image by using the from keyword, which we are very familiar with. So I will say from NGINX, and I will use the colon now, and it will be version 1.19.2, and then I like to say hyphen alpine like that. And that will be the image that I'm interested to pull now. So the next line will be responsible to basically grab the custom configuration and override the default configuration that is located at a specific directory within this container that I already know. So the directory might look a little bit confusing for you, but this is just a basic Linux directory that comes in with this alpine image. So I'm going to use copy, and I'm going to copy my configuration, which I named conf, and the destination of that will be /etc, and again /nginx. So this is now a directory within the nginx container that is going to spin up in the future, and the location of the default conf would be at conf.d. so this is another directory. And then we'd like to say that we'd like to override this with default.conf like that. So this line will give us full control of the configuration of the NGINX service. Alright, so now let's see what configuration NGINX will support and its unique syntax that sometimes could look very confusing, but I will really try to explain line by line what I'm doing. So the configuration should start with a default keyword that is named server like that. And then since the rest of the configurations are going to be related to the NGINX service itself, then now we have to open up and close the curly brackets and press enter, and then continue including some more configuration within these curly brackets. So now I'm going to say that I'd like to listen to port 80 within this reverse proxy. So it will be as easy as saying listen, and then we will have to go here and say something like 80 like that. Now this configuration needs to be created with a semicolons, so I will type in here semicolon to really specify that this is the end of that specific line. And the next thing that I'm going to say here is the server name. So I'm going to say server underscore name, and that will be basically localhost like that. Okay, so now that we have those configurations, then I didn't do anything too much complex till now. Basically, I just said that I'd like to listen to port 80, and then my server name will be localhost, and that's it. Okay, so the next configuration that we want to set up now is a specific configuration that will be responsible to take all the requests that comes from a client and to pass it to the running Flask application. Now, if you think about it, when me as a client tries to access that expected running Flask service, first I'm going to meet with this NGINX service, because I am not going to specify the port number when I'm navigating to a random website. So for example, if you think about it, even in my website, you only specify that you would like to navigate to a specific domain name like gymshapedcoding.com. but you never specify the port 5000 because it is a Flask instance that executes. And that is why we first meet with this NGINX service, which is being hosted in port 80. But this is exactly the place where we'd like to specify that all the requests should be processed and then passed into the running Flask application inside that server. So this is why I'm going to write the following configuration in here as well. So I will say location, and then I will say / like that to specify that the location is at the root directory. And then I'm going to say curly brackets like that and go inside these curly brackets one more time. And then here is the location that I'd like to specify where we want to pass in the request. So I will say proxy underscore pass, and then I will say something HTTP comma and then 2 times / just to basically create a URL. And then I will say web colon 5000 like that. Now this is where the location should be passed in port 5000. Now I know that you ask yourself why the hell you specified web. Now this is something that I want to leave you curious with, but you are going to see that just in a few minutes, because our Docker container is going to recognize the web keyword as a reference to the running Flask application. So we will see that just in a few minutes when I connect those two applications with the Docker Compose. And when I basically execute those two containers together, the entire picture will look very clean to you. And I just realized that I forgot the semicolon, so we'd like to specify that here as well because it is very important. Otherwise, the configuration will fail and we will not be able to spin up an NGINX container. Alright, so now that we have the proxy set up, then let's see how we are going to connect the Flask container with that NGINX container that we did not build and spin up yet. So for this purpose, as I said earlier, we are going to use something that's called Docker Compose. And by defining a basic YAML file, then we can basically spin up 2 or even more containers together and to really have a connection between them. So to get starting with Docker Compose, then there is one unique convent file that we need to create, which needs to be called Docker Compose. So I'm going to go to the root directory of our entire project and I'm going to create a file and I will name it docker-compose.yaml like that. Now again, this is one of the files that you only need to name it in that way, and be sure that you don't name it something else rather than what I wrote now. So I will create that. And now basically we need to include some basic YAML syntax to really describe that we need to spin up those two containers together. Now for sure in the future I will also include the database itself, but let's just start with the NGINX and with the Flask. Okay, so first we need to specify which version of Docker Compose we'd like to work with. So this is why we should say version 3.7 like that. Now don't get worried if you don't have the auto-completion like I do, because basically this is a plugin that you can install if you use PyCharm, and for sure this is something that you can install as well. And if you watch the tutorial of Docker as I suggested in the beginning of this tutorial, then you should already have this plugin. Okay, so once I specify the version, then we should open a new object that should be named services like that, because we want to specify what kind of services we'd like to use. So this is why we create this object, and then once we will press enter, then we need to make sure that we have 2 spaces for the indentation like that. Alright, so the first service is going to be the Flask service, and we'd like to name this service something like web, so I will do that. And then once I declare this, then we need to now think like we spin up this container, but we kind of define it with YAML syntax. So okay, we have a service named web, and then we want to say to that web service, where is the Docker file that needs to be built? So the Docker file of the Flask application is inside the web directory. So this is why I will say build, and I will use : and and I will say web like that. And this line just says something like, okay, go to the web directory from here and build the Docker file within this directory. So this is what this line does. And once I have done this, then there are going to be more pieces of information that I'd like to specify under the web here. And the next piece of information could be something like restart, always like that. And this line will be responsible to always try to spin up a container even if there is some generic failure. So this is a great idea to add this line here. And the next thing that we'd like to say now is the information that we probably use within the command when we spin up this container throughout this tutorial. So if you remember, I already had a documentation of that long command that we wrote to run a container based on the Flask image. So let me open the run.py command, and actually let me split the panes so you can really see the comparisons of how you can spin up a single container or to combine multiple and then declare it with YAML file. Okay, so I'm going to do something like that, and I will open the Docker compose in this side and then this one in the right side. Okay, so if you remember, we had this piece of information about -p 5000 to 5000. So this line was responsible to expose the port from the container to our local machine. So I'm going to again specify the same information, but this time this is going to be with YAML syntax. So we can say ports, and then I will say colon, and I will enter within this block. And then since this expects for a list object, then I can just say dash space and basically use the same value of this one. So I will copy that and paste this in like that. And the next piece of information that we'd like to specify is the additional environment variables that we'd like to have in this container. So this will be as easy as environment colon, and then the key values that you'd like to specify again with a list object. So it will be dash, and we can basically now say that it should include debug equals to 1. Now, I don't know if you are too familiar with YAML syntax or not, but I just forgot to specify that I have a video which is 50 minutes long that you can watch on my channel that really covers everything that you need to know about YAML syntax. So this is a great idea to maybe take a look, even a few minutes should do the job for you. And actually this is great now because now we have control if we'd like to run the application in debug mode or not, and it will be as easy as to change it to something like 0 in case that we'd not like to run this in debug mode. So let me revert this now to 1 because we want to use the SQLite 3 database. Then this is why I have debug equals to 1. Okay, so the next piece of information should be about the network of this application. Now, this is a new Docker topic that we did not talk, but when it comes to Docker, you can create your inner networks and you can include containers in them. So I will just say networks, and I will now create a random network. So I will name it Flask network like that. And the reason I am doing this, it is because in the future that I'm going to also declare the proxy, which is the NGINX, then I'm also going to include it in the same network as this Flask application. And then those applications will know how to connect to each other. So this is perfect. And this is why you have to use this Docker network utility. And this is a great idea to specify those key values in here as well. Okay, so now that we have done everything that needs to be declared in the web block, then I'm going to enter and indent out a couple of times until I reach here. And I want to make sure that I'm in the same indentation as this web, and that is perfect. So now we'd like to spin up the NGINX, and this is why it is a great idea to now say that we'd like to have one more container, and we can now name it proxy like that. And the process now is pretty much going to be the same like we have done previously for the web, because we now like to say that we want to build the Docker file within the proxy directory. So I will say build, and then colon proxy like that. And we'd also like to say that restart equals to always, because this is a great idea. And now about the ports of the NGINX. So if you remember, we said that we'd like to have our application in port 80 because this is the common port in all web applications. Unless you have certificates, then the port is going to be 443. But in our case, we are not going to include certificate in our deployment. So this is why we like to use port 80, which is HTTP. So we can say ports, and we can basically say that 80 should be mapped to 80 inside the container, exactly like we have done here. So this is pretty much the same process. Okay, so the last piece of information should be the network itself. So again, this will be something like networks, and I'm just going to grab the same value of here. So let me just delete that and paste this in like that, because we want those containers in the same network. So this is why I have done this copying and pasting. And now I think we are pretty much ready, and let's press enter and basically indent to the latest line that is possible. I mean the first line. Okay, so as you see, now we have two services, which this one being the Flask application and this one being the NGINX service that we'd also like to spin up. So now the last value that we should specify at the first index in the next line is the networks that this compose file needs to use. So I'm going to say networks like that, and let me add an enter so we will have a nice separation. And then I will only say that the network that this compose file should use is the exact same network that we have used throughout the definitions of those two services. So I'm going to say flask underscore network, and you need to specify a colon here like that. And this should really be it. And now we should be ready to spin up those two containers in one command and to really test out the results of it. Okay, so let me close this run.py from here and close this one from here as well, and zoom this up a little bit and open up our terminal within the root directory of that project. Alright, so now that we have opened our terminal, then we should understand how we are going to spin up those containers in one command referring to the YAML file that we have just completed to write. So when you install Docker desktop on Windows, then it is basically going to come with another Docker command line interface that is called docker-compose like that. So if you have really followed at least the first 15 minutes of my Docker tutorial, which I suggested to watch, then you probably installed Docker desktop on your Windows machine. So this is why if you try to use docker-compose in your terminal, then you should receive some result and not error. But if you want to basically install Docker Compose on any kind of machine that you use, then you can follow this documentation, which I will provide the link of that in the description itself. So just to really prove you my point, then you can see that inside this documentation we have some reference about install compose, and you can see that under this paragraph it says to us Docker desktop for Windows includes compose along with Docker apps. So most Windows users do not need to install compose separately. So this really means that you should have it on your computer, but if not, then you can follow this documentation, which I will provide the link of that in the description, and really install this specific CLI of Docker Compose and really to follow along with me. So let me go back to terminal and continue from here, and I will clean the screen. Now, the only thing that you need to do is basically say docker-compose up like that, and that's it. That's it. Then you will have your two containers spinned up. And if I press enter in here, then you can see that we got some errors. So it says to us that version in Docker Compose is invalid. It should be a string. So I think that the version up top in the first line should be fixed. And yeah, we should go here and fix that basically by using double quotes, and this should be it. And now if I open back our terminal and clean the screen, and really try to execute this one more time, then you can see that we have the first image being built like we expected. And now the NGINX image should be get ready as well. So let's wait a minute and see the results. Okay, so we can also see that we have the NGINX. Let me clean this smaller now. And you can also see, so this is the completion of the Flask image. And here we see that we got also the web and we also got the proxy itself. So this really means that we have both of the services installed correctly. Now you can see that we kind of have an interactive mode within this Docker Compose. But before we fix that, let me open my Chrome browser and really test the results. So let me bring back our browser and change this location to our local host and to basically say that 127.0.0.1. And now I don't really have to specify any port because all the browsers are trying to connect to an application with the HTTP, which is port 80. So now if I press this IP, then you can see that we are inside our application. And that is perfect because we were able to create the NGINX instance as expected, and it redirects our requests to the inner Flask application that runs together. So this is really nice, and we are getting close to having a ready production project. Alright, so now that we were able to spin this Docker Compose, then I want to show you something that is related to the configuration of NGINX that I said that I will explain later. So let me open PyCharm here and let's split the panes with the configuration file like the following. Okay, so on the left pane we got the Docker Compose file, and on the right pane we got the configuration file that the NGINX uses. Now if you pay attention, on the right side I used as the proxy pass value this URL, and you might be confused about this value because I automatically said that we should go to web, but we did not quite understood from where this web comes from. So this actually comes from the value of our service name. So you see, when we create services within Docker Compose under the services block, then it means that that is the domain name that we could access it by referring it. So this means that if I was to change the service name from web to something like my_service, then this means that now I changed the inner domain name that makes this container accessible. So this will mean that I should also change this to my_service, because in that case I only refer to a domain name of another container, and since they are in the same network, which we have declared here and as well as here, then I have the access to basically point to that domain name by using the value of web or my service if I was to leave it like it is. But actually it is a greater idea to change this back to web. So I just wanted to talk about the idea of the value in this configuration file, and this is really comes from the fact that I can access it basically by referring to the service's name. Okay, so there's actually one final thing that we have to customize before we go ahead and create the database instance within this Docker Compose file. So I just want to revert this environment variable back to 0 to not having a debug equals to true situation. So I'm going to just change it to something that is not 1. And now I'm going to go back to our terminal and I will say Docker Compose up like the following. So let's zoom out a bit and see the results. Now I did not talk about this yet, but actually when we execute our application in debug equals to false, then there are still some warnings about how this Flask application is still not running in production mode. So this actually comes from this warning that says us this is a development server and we need to use a production server, and for that purpose we need to use a WSGI server. Now when it comes to a web framework like Django, then it already has some files that deals with WSGI servers. But when we talk about Flask, we need to spin a WSGI server on our own. So what that means, it means that we cannot allow ourselves to leave the Docker file as it is, because it will keep running our application in this development mode like it says here in the warning. Now I know that this is something that we could change from the very beginning of this entire series, but I just wanted to wait with it because it is important to differentiate between what an NGINX does to what a candidate for WSGI server could do. So we need to create WSGI server to handle Python code, meaning the Python requests that are going to basically do stuff like interacting with database. So this is the stuff that Python does. But when it comes to NGINX, then it is mostly going to deal with style files, which are so-called static files that we rarely use in this project. So this is why we have to have NGINX for handling styling, and we have to have WSGI server for handling Python code better, and this will basically allow us to have a production server and not a development mode server like we have now. Now, leaving this like it is just not a great idea because this is not designed for production purposes. So we are going to use a WSGI server that is called Gunicorn, and for that we need to go back to our requirements.txt file and actually add this as a library and then do a few of customizations to our Docker file. So let's go ahead and see what we should do. So I'm going to open our PyCharm here. And now I am going to go back to our requirements.txt, which is inside the web framework. And I'm just going to include one more library within this requirements.txt file, and it will be the Gunicorn WSGI server. Now this will go ahead and install this package within our container, and it actually comes with a built-in CLI, so it means that we can now use commands with the prefix of Gunicorn. So we are going to customize our CMD commands within the Docker file because now Gunicorn is going to be recognized as a built-in command in our command line interface. So this means that we can go to our Docker file and actually change the method that we execute our application. Now this is the exact line that causes the warning that we saw where it says us that this is a development mode server. So besides, we need to change it to being run with Gunicorn, and it will be a command that will look like the following. So I will say Gunicorn, and then I have to point to the module where our application executes. So if you remember, our application executes in run.py file, so I can say run. And then it expects for the instance of the Flask application right after the colon sign. So I'm going to say app here like that. Now, before we go ahead and execute this, actually in Gunicorn documentations, there are recommendations about running this with different workers when it comes to execute it. So we can actually create multiple workers that will be responsible to manage the traffic from everywhere. So we can say that we'd like to create 3 workers, and actually this is a convention when it comes to running servers in a minimal server. So we are not going to spin up this fancy server with like 32 gigabytes of RAM and multiple cores. Besides, we are going to do that with a minimal server with 1 core. And with servers that having 1 core, it is recommended to spin up the Gunicorn with 3 workers according to their documentations. So I'm going to say here -w and specify the argument of 3 like that. Alright, so there is actually one final argument that we have to pass in to really spin up this Gunicorn successfully. Now, if you remember, if I go now to the run.py, then we actually controlled the host with this IP and this port. So what that means, it means that we also have to pass in similar arguments to the Gunicorn itself. So I'm going to go back to our Docker file and say here --bind, and I will pass in 0.0.0.0:5000 as the port, and this should really be it, and go ahead and spin up our Flask application with Gunicorn. So one final thing, I'd actually like to comment this command in here to really remember that I have the option to later comment this out and uncomment this out when it comes to basically running our application in debug mode when we need to. So I'm going to comment this out and open this up to test if everything now works properly with the Gunicorn. So I'm going to go to our terminal and basically execute docker compose down now. So you can do this just to basically get rid of all the previous executions. And now before we go and say docker compose up, we should go and rebuild the images because we had some changes. So I'm going to say -- build. And now if I run this, then now we can see that the logs are quite different right now because we execute the Flask application with Gunicorn. And you can see that it says us listening at 00005000, and actually there are 3 workers. So it means that everything really works properly. Now to test this out, we need to go to our Chrome browser and see if everything works properly when we go to our localhost IP. Because like I said, when it comes to handling the request, we are first going to meet against the NGINX, and the NGINX is hosted with port 80. So I'm going to bring our browser here and try to see if everything works. And you can see that everything works properly like expected. And now we actually got the debug mode equals to 1. If you remember, I changed this to 1 to have the SQLite 3 database. So it means that I can register to that website. So it is a great idea to test if everything works as expected before we go ahead and proceed with some more things. So I'm going to create a new account like JSC10. And I'm going to mismatch the email, so I'm going to use a not valid email. And now I will try to create account. And you can see that we got the email error. And now let's try to do this with valid email. So I'm going to say something like that. And if we create account, then you can see that it says us email already exists. And actually this is great because I forgot that we used it. So I'm going to change this to something else and test this out. And if we create account, then you can see that everything works as expected. And it means that the Gunicorn did not really affect the functionality of our website. So it means that we can continue on from here, spinning our Postgres database. Alright, so I know that we covered a lot of new information, and if there is something that you did not understand till now, then feel free to comment this out in the comment section, because I know that I discussed about a lot of new technologies that I did not have any tutorials on them, and pretty much each thing that I'm doing here is new to you, so feel free to comment out if you have any questions. Okay, so now that we were able to spin up this container and as well as this one, now it is about time to work on our database. Now this will be the last step of the design that we are going to complete to the Docker Compose, and then we are going to grab the entire project and move it to some production server that we will create on Linode, which is a comfortable cloud provider that we are going to use. Okay. So now the third service, it makes sense to name it something like DB, and then we are going to see how we are going to spin up a Postgres container. Now there is also the option to pull directly the image from Docker Hub without really referring to some Docker file, unlike we did with web and proxy. So if you remember, I said that we should build the Docker file within the web directory, which is here. So in that case, I can also specify the image name and it will pull it directly from Docker Hub. So I will say image, and that will be equal to Postgres like that. Now, since I want to work with a specific image, then I will say :13 like the following, and from here we are good to go. So let me minimize this back so it won't confuse us too much. Okay, so like before, I like to say that we always like to restart this container if there are going to be any failures, so I will leave it as it is. And now let's talk about the ports. So the port of the Postgres container by default is going to be 5432. So I will say ports, and then I will say -- and then I will map the container port to the local port of my computer. So it will be 5432:5432 again, like that. Now this is by convention something that you want to do because Postgres service by default is designed in a way that it runs on this port, so just write this value and nothing different than that. Okay, so now that we have this set up, then we also like to specify some environment variables and as well as the network. So the network is again going to be the same as the web and the proxy. So I'm just going to copy that and paste this in like the following. Okay, so from here we also like to specify several environment variables that the Postgres is asking from us. And actually those are mandatory environment variables that you have to fill in. Otherwise the Postgres container is not going to spin up properly, because again, this is how the Postgres itself is designed from their side. So this is not something that is dependent on us. This is the way that the image is designed. So we have to say here environment, and then we will fill in several environment variables under this environment block. Now, if you remember, we already have information about the specific information because we already wrote a production configuration in the Flask application itself. Because if you remember, this is the production database that we should spin up. And from the very beginning of this entire tutorial, we wrote a config.py file that includes those pieces of information. So I'm just going to look for that. And this should be under web, market, and then the config.py file. So let me split the panes here. And let's go back to our Docker compose. So let's write down the environment variables that the Postgres image expects from us. So first one should be Postgres underscore user, like that. And I'm going to duplicate those lines by Ctrl D a couple of times. And then I will change this to pass. So we got username, password. And we also need to specify the database name, so I will change this to DB. Now I'm going to pass on this one because I thought that we also need to specify the port like that, but we actually not need to do that because we already exposed the default port, so I can give up on this value. Okay, so the environment variables are going to be passed in by separating them with an equal sign. So I'm going to say that this should be equal to admin, and the password is going to be equal to admin as well, and the database needs to be marked like that. So I know that we have a duplicated values in here and as well as there. Now, as I said, I don't really want to focus too much on securing things up, and I just want to go forward with some deployment example with Docker Compose. And I already feel like I explained a lot of new things that might be the first time that you see this. So I don't really want to make everything in the most best practice way. Sometimes I might leave things a little bit more simple. And if you like to change the behavior of the way that you store passwords in this config.py file that we created, then you already know how to do that, because you can change this to something like os.environ.get, and you can read an environment variable that is going to be passed in from the Docker Compose file. So just for your information, there is always a room to improve things up. So I will remove that and continue from here. Okay, so there is one final thing that the database container needs in order to store information for a long time. Now, when it comes to containers, basically the containers are not designed by default to maintain information for a long time. So what that means? It means that if I was now to spin up a Postgres container and to exit this container in some time from now, then I will end up by losing my information in that database, because the containers are not designed in a way that they are just going to keep information forever. So when it is exited, then you basically lost all your data. But actually, Docker comes with a feature that is called Docker volumes. So a volume is a logic unit that you can point to your container, and then this volume will be responsible to maintain your information, and then you will have persisted info that is going to be stored for whatever time you like to, even if you close your service or even if it's crashed in some time. So the way that this should be defined in the YAML file is by the following way. So let's see that one. So I'm going to go outside of the environment variables, and I'm just going to say volumes colon, and then I will just say that we'd like to create a new Docker volume and mount it to some directory inside the Postgres container, and this way I will grab the information that is stored inside the container to a volume that I can have it persistent, and the information will always remain. So I will say Postgres data. So this is just a random name that I wanted to create, and I will mount it to this directory. So I already know that this directory is a very unique directory within the Postgres where all the information is going to be stored. So it will be var and lib PostgreSQL / data, like that. So those lines are very critical if you don't want to lose data. So make sure that you add this in your DB section. Okay, so now that we have this up in here, then we also need to say that this Docker compose is actually dependent on some volume like we did with the networks. So it will be as easy as saying volumes, and then I will go here and say Postgres _data, like that. And I will add the colon sign because this is mandatory. And now our Docker compose file is ready, and let's test the results in the terminal. Now, before we really get into the terminal, I just forgot that the environment variable of debug within the Flask application is set to 1. And we probably want to change that to something that is not 1, because actually it is a great time to test if the connection to our Postgres database will work as expected. So I'm going to go to our PyCharm very quickly and revert this back to 0, like that, because we want to test the connection to our Postgres database. So now I'm going to go back here and say Docker compose down once again. And actually, I know that I used a lot of Docker compose commands throughout this tutorial, and I did not show you this useful command. So actually, if you go ahead and say Docker compose -- help, then you will get a list of all the available commands that you can use with Docker compose. So just know that this is a great option, and you get a wonderful list with all the options out there. So this is actually a great utility when you want to remember some command that you forgot. Okay, so I'm going to now say again Docker compose up -- build, like the following. Now, there's actually a great reason that I'm doing this, because we want to build the Postgres image. Now, I'm also going to say here something that will look like -d. Now, -d will run the composed applications in detach mode. And this means that we are going to execute all 3 containers, and then we are going to go back to our terminal session like we expected, and we are not going to receive these interactive logs when we execute the command, because the containers are going to run in the background. So it means that we don't need to be interrupted with the logs. So I'm going to say something like the following, and let's wait for the results now. Okay, so as you can see, creating DB, web, and proxy, and now we are back at our terminal. So now, if we want to see if everything is up and running, then we can say Docker compose ps, like that. And this will display the status of all the containers that we spinned up. So I'm going to say enter. And you can see that DB is up, and proxy is up, and the web is up as well. So now we want to test if we can again register to that website with some account, because we want to test if the interaction against Postgres database will work as expected. So now I'm going to go back to our web browser again, and I'm going to refresh this page, and you can see that we got some errors. So now we can ask ourselves what we should do to figure out what the errors are. So it will be as easy as going back to our terminal and say something like Docker compose logs. And if I press enter in here, then you can see that I see each log about each application. And I actually can see now the exception in the web container. So I'm going to scroll down, and you can see that it says in here, is the running host localhost and accepting TCP IP connections on port 5432. So it means that we have a connection error, and we have to figure out where it comes from. So now I'm going to go back to our Docker compose, and I am going to make a kind reminder about what we have done to the config file when we created this NGINX container. So if you remember, I will open the config.py in proxy, and if you remember, let me splint the panes in here like that. Okay, so if you remember, we used the domain name of web to actually connect the NGINX to the Flask application. And the reason we have done that, it is because we have to send the traffic coming to this NGINX back to 5000 port on the host of Flask. And the domain name of that container of this Flask host was web, and its name is web because we called it web. So it means that we have to refer to our database with its domain name, which is DB, because it is just the same as we have done with this configuration file where we pointed to this domain name, which is called web. So now the error is actually coming from web, market, and config. So now you can see that the host is localhost, and that is incorrect because it needs to be DB, because this is the domain name of this database. So once I will change this to the same value like this one, then everything should really work. So I'm going to take down everything and spin them up again. Okay, so in the terminal, as usual, I'm going to first say docker compose down like that. And let's wait till everything really gets down here. Perfect. So now we should go ahead and basically bring this up again. So I can say again docker compose up -- build and then use the detach mode. So I'm going to run that. And now once we got this, let's test if everything works well. So it will be docker compose ps. And I can actually see that the DB is trying to restart itself. So let's try to hotfix that. So I'm going to say docker compose logs, and basically let's see what is going on here. And let's zoom out the log a little bit. And it actually complains about password is not specified. So I probably know this issue, but you can see that it asks for the Postgres password environment variable and not Postgres pass. So I'm going to change this in the docker compose file, but I'm actually not sure why this error occurs. Because in some cases, when I passed in environment variable as equals to Postgres pass, then it worked great. So I will try to go back to PyCharm and change this out. So I will go here, and I will change this to being password like that. Now I'm going to be honest, I'm not sure why we did see this error now, but if pass doesn't work for you, then just try this out with password. So I'm going to save our changes and try to rebuild this one again. So it will be clean screen, docker compose down, and I will say docker compose up, build, and -d like before. Alright, so now if we clean the screen and try to do docker compose ps, then you can see that now everything works properly. So again, I'm not sure about the environment variable thing, but I believe that this might be related to versions. So sometimes try to pass in pass or password, but actually it is a great idea to check this out, and if I will find the answer for that, then I will comment this in the comment section. Alright, so now that we have the database spin up, then let's test the results. So again, it will be just going to our web browser and try to see if everything functions. So now if I go to here, then again we see some errors, but I think this should be expected because we don't have the tables of the database created yet. So I assume that this is the error that is going to pop up now, and I will show how to fix that as well. So if I go again to Docker Compose logs and see the logs about web, then we can see that it really complains about undefined table. So it means that we have to execute this db.createAll command that will really be responsible to create all the tables that we have defined back in the tutorial in our modules. So actually, to show you this up, if I go to our project and visit the modules.py file, now I will allow myself to ignore those because it happens from the PyCharm and this is not related to really syntax errors. And this actually comes from this user that did not really migrate as a table, and as well as this one. So it means that we have to figure out how we are going to execute the database table creation commands. So to do this, I'm going to go to our terminal and clean the screen. Now, I did not talk about this before, but there is actually an option to execute some commands inside running containers. And it will be by using the docker exec command. So to do this, then I'm going to bring the name of our container. And I can do that by using docker compose ps. So this is actually the name of our Flask container. And I can say now docker exec, and I can do this with interactive mode. So I will really kind of do like an SSH session with my container. And this goes something like the following. So I can say docker exec, and we'd like to do this by --it. So this stands for interactive mode. And then I will specify that the container that I'd like to execute some commands in is actually flask market underscore web underscore one. So this is exactly like this one. And to actually execute in interactive commands within our containers, then we have to open the bash terminal. So it will be /bin and /bash like that. And as soon as I can do this, and I think this should be one dash here, so sorry about that. And now if I run this, then you can see that I'm totally inside a different sort of machine in quotes, but I'm inside a container. So now I can say something like dir, for example, and you can see that I see everything like in our Flask project. So it means that I'm inside the container. Now I can basically go and say here Python and basically execute the commands that we used to execute in our Flask tutorial to migrate the tables. So it will be from market import db, and now that I have done this, then I can allow myself to execute db.createAll, and it will go and create the tables for us. So if I run that and I don't receive any errors like the following, so it means that we are good. So now I can exit from the Python and I can actually get out from this container by writing exit again. And just to verify that everything runs, we can use again docker compose ps, and everything is really up and running. So now it is about time to test our changes one final time, and it will be again by trying to create a new account, because this is how the Flask will try to interact with the Postgres database. So in our browser, I can basically try to go here again, and I will try to register, and let's create now JSC 20, and I will use this email, and let's try to also create this password. And if I click on create account, then you can see that now it works okay. So it means that the Flask application knows how to connect with the Postgres database, and our Docker compose file is pretty much complete. And now we have to kind of organize what we have to do in the destination server where we will move this project. So now we only need a server with Docker Compose command line interface, and we need to go inside the Flask container and create our tables. And that will be it. That will be basically everything that we need to do to come up with our organized Docker Compose application. And those steps will be something that I will be completing in the third and the last part of this tutorial. Alright, so I know this might be a lot of information that needs to sink in, so if you have any questions about this second part, then feel free to ask in the comment section. And I really hope that you enjoyed this part of the series as well, and if you enjoyed it, please hit the like button and as well as consider subscribing to my channel. This will really help me to spread this video across more people. Alright, so see you very soon in the third part of this series.